Deep in Lebanon's Bekaa Valley, where the morning sun casts its first light across ancient stones, lies one of archaeology's most confounding mysteries. The ruins of Baalbek rise from the earth like fragments of a forgotten world, their massive blocks defying every explanation we've constructed about the past. Here, stones weighing more than 1,000 tons rest with impossible precision, fitted together as though gravity itself had been negotiated away. The Romans built temples here, yes, but beneath their familiar columns and arches lies something far older, far stranger, a foundation of megaliths so vast that modern cranes strain to lift their smaller cousins. Stand before the trilithon, three horizontal giants that anchor the Temple of Jupiter, and the mind struggles to process what the eyes report. Each stone stretches nearly 20 meters in length, 4 meters high, 4 meters thick. Together they weigh more than 2,400 tons, yet they sit as calmly as books on a shelf, placed there by hands we cannot name using methods we cannot fathom. The precision is surgical, the gaps between them thinner than paper, the alignment perfect after millennia of earthquakes and storms. These are not rough-hewn monuments to brute force. They are expressions of knowledge we have forgotten how to possess. But the trilithon is merely the visible edge of something deeper. 900 meters away, in the ancient quarry where these titans were born, even larger stones wait in eternal stillness. The stone of the pregnant woman, carved and shaped but never moved, weighs 1,000 tons. Beside it lies the forgotten stone, recently uncovered, estimated at 1,650 tons. That is the weight of 3,300,000 pounds, a mass equivalent to 9 blue whales carved from a single piece of limestone. The quarry holds them like unfinished sentences, as though their builders simply vanished mid-thought, leaving behind only the echo of impossible ambition. The silence of the stone speaks louder than any inscription. No Roman text describes lifting blocks of such magnitude. No Byzantine chronicler records their placement. No Arab historian explains their purpose. They exist in a void of documentation, monuments without memory, achievements without acknowledgement. Even their builders seem to have evaporated, leaving behind only the physics-defying evidence of their presence. The conventional story tells us these are Roman foundations, quarried and placed during the height of imperial engineering. Yet the Romans themselves built their temples on top of these megaliths, treating them as they would natural bedrock, ancient even in antiquity. Archaeological layers reveal the truth in stone. At the bottom, massive blocks fitted with impossible precision. Above them, smaller but still substantial Roman stonework. Two distinct building phases separated not by decades, but by what appears to be millennia. The megalithic era forms the foundation, silent and anonymous. The Roman era adds decoration and identity, claiming credit for what it merely inherited. This is not unusual in archaeology, where each civilization builds upon the ruins of those before. But at Baalbek, the gap between foundation and superstructure suggests something more profound than simple renovation. The bottom layer represents a technology we cannot replicate, while the top reflects methods we understand. Between them lies a chasm of lost knowledge. Consider the engineering challenge these stones represent. Moving the largest blocks from quarry to construction site required traversing 900 meters of uneven terrain. No ramps have been found, no traces of the massive infrastructure such transport would demand. Modern attempts to recreate ancient lifting techniques fail spectacularly when confronted with even modest weights. The experimental archaeology of moving multi-ton blocks reveals the limitations of ropes, levers, and human muscle. Yet somehow, in an era we assume possessed only the most basic tools, builders not only moved these colossal weights, but lifted them 20 feet into the air and placed them with millimeter precision. The mathematics of the challenge grow more impossible with each calculation. To move a 1,000-ton block using rope and wooden rollers would require thousands of workers coordinating with perfect synchronization. The friction alone would demand constant lubrication across nearly a kilometer of rough ground. The logistics of feeding, housing, and organizing such a workforce exceeds anything documented in the ancient world. Yet the stones moved, they rose, they settled into place with an accuracy that modern construction rarely achieves. The evidence demands explanation, but every explanation dissolves beneath the weight of physical reality. What emerges from this impossibility is not the story of how these stones were moved, but when and why they were abandoned. The unfinished blocks in the quarry tell a tale of interruption, of work stopped mid-process and never resumed. These are not stones set aside for future use, but monuments frozen in time as though their creators simply vanished. The precision of their shaping suggests the work was nearly complete. The stone of the pregnant woman shows tool marks consistent across its entire surface, evidence of systematic quarrying following a unified plan. Yet it lies exactly where ancient hands left it, neither moved nor reused, as though the knowledge of how to transport it died with its makers. Legends cling to these stones like morning mist, refusing to dissipate under the sun of rational inquiry. Local traditions speak of giants who built the platform in the earliest days of the world. Cain himself, according to one chronicle, raised these walls in a fit of divine madness, naming the city for his son Enoch and peopling it with beings of superhuman strength. The myths feel absurd until you stand before the stones themselves, when the absurdity transfers from the legends to the conventional explanations. Giants begin to sound less impossible than cranes. The site's religious significance spans every civilization that encountered it. Canaanites built temples here in the Bronze Age. Phoenicians worshipped their gods among these stones. Greeks renamed it Heliopolis, the city of the sun. Romans constructed their grandest temples upon the megalithic foundation. Byzantines converted the spaces to Christian worship. Arabs incorporated the complex into Islamic tradition. Each culture found something sacred in these stones, something that transcended their particular beliefs and spoke to something deeper in human consciousness. The continuity suggests that whatever power drew the first builders to this place continued to resonate across millennia. Yet beneath the layers of religious interpretation lies a pattern more intriguing than worship. The megalithic platform aligns with celestial bodies, its angles and orientations encoding astronomical knowledge. The precision required for such alignments demands not only advanced mathematical understanding, but also long-term observation of stellar movements. The builders possessed knowledge of celestial mechanics that rivals modern astronomy, embedding it in stone as though the monuments themselves were meant to preserve what books and scrolls could not. This is where the conventional story breaks down entirely. We are asked to believe that Bronze Age peoples, working with copper tools and rope, not only moved blocks weighing more than modern skyscrapers, but did so with astronomical precision and mathematical perfection. The technology gap yawns like a chasm between what we assume they possessed and what the stones prove they achieved. Either our understanding of ancient capabilities is catastrophically wrong, or these monuments belong to a different age entirely, one whose technology we have forgotten rather than never possessed. The question becomes not how they built Baalbek, but who built it and when. The evidence points away from the civilizations we know towards something older, something lost. The precision of the stonework, the impossible logistics, the astronomical alignments, and the mysterious abandonment all suggest builders operating with knowledge and capabilities that disappeared from the historical record. The Romans found these stones already in place and built upon them, claiming by inheritance what they could never have created by invention. If that is true, then Baalbek becomes something far more significant than an impressive Roman temple complex. It becomes a remnant of a vanished world, a fragment of lost knowledge preserved in stone. The megaliths stand as evidence not of human limitation, but of human capability, proof that our ancestors achieved what we struggle to imagine. The question then shifts from engineering to history, from how to when, from possibility to memory. Something built Baalbek. Something possessed the knowledge and power to quarry, transport, and precisely place stones that dwarf our modern achievements. Something understood astronomy and mathematics well enough to encode complex knowledge in monumental form. And then something happened to erase that capability from the world, leaving behind only the stones themselves as testimony to what once was and might yet be again. In the silence of the stones, in the precision of their placement, in the mystery of their abandonment, lies a story that archaeology has barely begun to tell. A story that reaches back beyond recorded history into ages we thought were primitive, revealing sophistication we thought was modern. The Baalbek Stones do not merely challenge our understanding of the past, they demand that we rewrite it entirely. What forces could erase such mastery from the world so completely that even its memory vanished? The answer may lie not in the slow decay of civilizations, but in the sudden violence of cosmic catastrophe. Across the planet, evidence accumulates of a global disaster that struck at the end of the last ice age, an event so devastating that it reset human civilization itself. The timeline aligns with unsettling precision to the mystery of Baalbek's abandoned stones, suggesting that the builders of these impossible monuments may have been victims of forces beyond earthly comprehension. 12,800 years ago, something fell from the sky. Not a single object, but a cascade of destruction, fragments of a disintegrating comet that struck Earth's atmosphere in a bombardment spanning continents. The evidence lies buried in sediment layers worldwide, a forensic record written in shocked quartz and microscopic diamonds, in platinum spikes and glassy spherules that could only form under temperatures exceeding 2,000 degrees Celsius. These are the signatures of impact, the calling cards of cosmic violence preserved in stone and soil from North America to the Middle East. The event has a name among scientists, the Younger Dryas impact hypothesis, though the clinical terminology barely captures the scope of devastation it describes. In a geological instant, global temperatures plummeted. Ice sheets that had been retreating suddenly surged forward. Sea levels dropped and rose in chaotic succession. Massive wildfires swept across continents as the atmosphere itself ignited from the heat of multiple airbursts. The stable climate that had nurtured late Ice Age cultures collapsed into chaos, and with it fell civilizations we are only now beginning to glimpse in the archaeological record. The timing haunts every investigation of ancient mysteries. While mainstream archaeology places the beginning of complex civilization at around 5,000 years ago, the Younger Dryas event occurred more than twice that distance into the past. Yet its fingerprints appear at sites that display technological sophistication supposedly impossible for their age. Göbekli Tepe in Turkey, with its massive stone pillars carved with intricate reliefs, dates to the immediate aftermath of the impact event. Its builders apparently possessed advanced knowledge of astronomy and stoneworking, creating monuments that would not look out of place beside the megaliths of Baalbek. The connection deepens when you examine what these ancient builders chose to preserve in stone. At Göbekli Tepe, the famous vulture stone contains what researchers now recognize as a star map, specifically documenting the constellation patterns visible around 10,950 years ago. The date corresponds almost exactly with the proposed timing of the cosmic impact. The builders were not merely creating art or religious symbols. They were encoding a warning, preserving in permanent form the memory of catastrophe from the sky. This practice of astronomical record-keeping in stone appears at megalithic sites worldwide, as though survivors of the impact event shared a common understanding that knowledge must be preserved in the most durable form possible. The precision of these celestial alignments requires generational observation and mathematical sophistication that challenges every assumption about prehistoric capabilities. Yet the evidence stands in stone, impossible to dismiss or explain away through conventional archaeological theory. The environmental devastation of the Younger Dryas event would have been immediate and overwhelming. Temperatures dropped by as much as 10 degrees Celsius within decades. Forests burned across continents, their charcoal remains forming distinct black layers in sediment cores. The impact winter that followed would have lasted years, blocking sunlight and collapsing agricultural systems that had sustained growing populations. Archaeological sites from this period show clear evidence of abandonment and cultural disruption on a scale that suggests not gradual decline, but sudden catastrophe. For any civilization that had achieved technological sophistication before the impact, survival would have depended on preserving essential knowledge through the chaos. Stone monuments aligned with astronomical precision would serve as both calendar and archive, encoding information about celestial cycles and potential future threats. The builders of Baalbek, working with capabilities that allowed them to manipulate 1,000-ton blocks with surgical precision, would have possessed exactly the kind of advanced knowledge that cosmic catastrophe could erase in a single generation. The geographical distribution of impact evidence aligns remarkably with the locations of humanity's most mysterious megalithic sites. The Younger Dryas boundary layer, containing the telltale markers of cosmic impact, has been identified across 4 continents spanning an area of 30 million square miles. Within this same region lie Göbekli Tepe, the pyramids of Egypt, Stonehenge, and dozens of other monuments that display engineering capabilities far exceeding their supposed age. The correlation suggests that these sites may be memorials rather than innovations, built by survivors who retained fragments of pre-impact knowledge. Consider the practical implications of such a catastrophe for an advanced civilization. Infrastructure would collapse immediately under the combined assault of earthquakes, fires, and climate disruption. Transportation networks would be severed, cutting off communication between distant centers of knowledge. The specialized expertise required to quarry and move megalithic blocks would be among the first casualties, as survival took precedence over monumental construction. Within a generation, the techniques that created Baalbek's impossible stones could vanish entirely, leaving behind only the monuments themselves as proof of what had been lost. The incomplete nature of many megalithic projects takes on new meaning in this context. The unfinished stones at Baalbek, shaped to perfection but never moved from their quarry, suggest work interrupted by catastrophe rather than abandoned by choice. The builders had achieved the most difficult part of the process, the precision quarrying and shaping of massive blocks. What they could not complete was the final transportation and placement, tasks that would have required the coordinated effort of large, stable communities with abundant resources. The cosmic impact would have shattered such communities instantly. Archaeological evidence from the Younger Dryas period shows exactly this pattern of disruption and abandonment. Sites across the globe display sudden cultural breaks, with sophisticated tool traditions giving way to cruder implements and complex settlements replaced by scattered camps. The transition suggests not gradual evolution, but forced regression, as though entire populations had been knocked backward in technological development. What we interpret as the slow rise of civilization may actually be the painful recovery from its near-complete destruction. The astronomical knowledge embedded in megalithic sites gains deeper significance when viewed as disaster preparation rather than religious devotion. Ancient builders who had witnessed cosmic catastrophe would understand the importance of tracking celestial objects that might pose future threats. The precision alignments found at Baalbek and similar sites could represent early warning systems, monuments designed to track the orbital mechanics of potentially dangerous comets and asteroids. Such knowledge, preserved in stone, would be invaluable to survivors and their descendants. Modern research into the Younger Dryas event continues to reveal new evidence of its global scope and devastating impact. Shocked quartz grains from the boundary layer show fracture patterns identical to those created by nuclear explosions, indicating pressures and temperatures far beyond any terrestrial process. The discovery of these impact markers at multiple sites worldwide confirms that the event was not localized but planetary in scale, affecting climate and human populations across continents. The recovery from such devastation would take millennia, with knowledge being slowly reconstructed from fragments preserved by survivors. Some capabilities, particularly those requiring large-scale coordination and specialized expertise, might never be fully restored. The precision stoneworking techniques that created Baalbek's megaliths could represent one such lost technology, surviving just long enough after the impact to complete a few monuments before vanishing forever from human capability. This interpretation transforms our understanding of sites like Baalbek from puzzling anomalies into precious archives. The stones become not just impressive engineering achievements, but repositories of pre-catastrophe knowledge, preserved in the only medium durable enough to survive global disaster. Their astronomical alignments encode information about celestial mechanics that took thousands of years to rediscover. Their mathematical precision preserves geometric relationships that form the foundation of advanced engineering. The silence surrounding these monuments gains new meaning as well. If they were built by impact survivors working with inherited knowledge, their builders would have been small, isolated groups focused on preservation rather than documentation. The absence of written records makes perfect sense in this context, as would the gradual loss of construction techniques as communities struggle to survive in a transformed world. The monuments themselves become the only testimony to their builders' existence and capabilities. The pattern extends beyond Baalbek to encompass a global network of megalithic sites that may represent humanity's first attempt at creating a permanent record of advanced knowledge. From the precision astronomy of Stonehenge to the mathematical constants encoded in the Great Pyramid, these monuments display a consistency of purpose that transcends cultural boundaries. They seem designed not for the societies that built them, but for future civilizations that might rediscover and decode their messages. If this interpretation is correct, then the megalithic builders were engaged in an act of profound foresight, preserving essential knowledge against future catastrophes. They understood that human memory is fragile and that civilizations can vanish, but stone endures. The precision and permanence they built into their monuments suggests they were working against time, racing to preserve what they could before the last echoes of pre-impact knowledge faded forever. The implications reach far beyond archaeology into questions of human resilience and the fragility of technological achievement. The Baalbek Stones stand as testament to capabilities that once existed and could exist again, proof that human civilization has depths we have barely begun to fathom. They remind us that progress is not inevitable and that the knowledge we take for granted could vanish as completely as the techniques that shape 1,000-ton blocks with mathematical precision. In the end, the mystery of Baalbek may not be how such monuments were built, but why they were necessary. If they represent archives of pre-catastrophe knowledge preserved in stone against the possibility of future disasters, then they serve as both memorial and warning. They speak of human achievement and human vulnerability in equal measure, monuments to what we can accomplish and what we can lose. The stones remember what we have forgotten, waiting in patient silence for the day we might remember how to listen. The evidence accumulates like sediment in geological layers, each discovery adding weight to a narrative that conventional archaeology struggles to acknowledge. Beneath the surface of accepted history lies a pattern of disruption so profound that it reshapes our understanding of human development itself. The cosmic bombardment that marked the end of the Younger Dryas was not a single event, but a prolonged assault that lasted centuries, with debris from the fragmenting comet continuing to rain down long after the initial impact. This extended period of instability would have made recovery nearly impossible for any civilization that survived the first wave of destruction. Recent excavations at sites across the impact zone reveal layers of ash and debris that tell the same story from different perspectives. At Abu Huraira in Syria, archaeologists have uncovered evidence of sudden environmental change that forced hunter-gatherers to abandon their traditional lifestyle and develop agriculture as an emergency survival strategy. The transition was not gradual evolution, but desperate adaptation, as communities that had thrived for millennia were suddenly faced with a transformed world where old methods of subsistence no longer functioned. The timing of this agricultural revolution coincides precisely with the Younger Dryas impact event, suggesting that what we celebrate as humanity's greatest technological leap was actually a response to catastrophe. The development of farming, the domestication of animals, and the establishment of permanent settlements may have been survival strategies rather than innovations, forced upon populations that had previously enjoyed more sophisticated ways of life. The monuments they left behind, from Göbekli Tepe to Baalbek, could represent attempts to preserve the knowledge of that earlier world, even as they adapted to harsher circumstances. This perspective transforms our entire understanding of the Neolithic revolution. Rather than marking humanity's rise from primitive hunter-gatherers to advanced agriculturalists, it may document our recovery from a far greater fall. The sophisticated astronomical knowledge embedded in megalithic sites suggests that pre-impact civilizations possessed understanding that took thousands of years to redevelop. The precision engineering required to create monuments like Baalbek indicates technological capabilities that we have only recently begun to match, if at all. Underground cities scattered throughout Turkey and surrounding regions add another dimension to this story of catastrophic disruption and survival. These elaborate subterranean complexes, some capable of sheltering thousands of people for extended periods, were not built for ordinary purposes, but as refuges against extraordinary threats. The Zoroastrian text Vendidad, believed to preserve oral traditions from the impact period, describes exactly such preparations, telling of warnings received about an approaching winter so severe that survival would require going underground. The scale and sophistication of these underground cities rivals anything built above ground during the same period. Multi-level complexes with ventilation systems, water supplies, and storage areas demonstrate engineering capabilities that challenge conventional timelines of technological development. Their builders possessed advanced knowledge of geology, structural engineering, and environmental systems that allowed them to create livable spaces deep beneath the Earth's surface. Yet these cities were abandoned just as mysteriously as they were built, their populations vanishing as suddenly as the threats that drove them underground. Archaeological dating of these underground complexes reveals construction periods that align closely with the aftermath of the Younger Dryas event. The Derinkuyu underground city, capable of housing 20,000 people across multiple levels, shows evidence of continuous occupation during the exact period when surface settlements across the region were being abandoned. The correlation suggests that these were not merely storage facilities or defensive positions, but genuine population centers designed to preserve human communities through extended periods of surface uninhabitability. The astronomical sophistication of megalithic sites becomes even more remarkable when viewed as disaster preparation rather than religious devotion. Modern analysis of Göbekli Tepe's Pillar 43, the famous vulture stone, reveals encoded information about the Taurid meteor stream, the same celestial debris field associated with the Younger Dryas impacts. The builders were not creating abstract art, but documenting specific astronomical observations, preserving knowledge of cosmic threats that could pose future dangers to Earth. This focus on meteor streams and cometary debris appears at megalithic sites worldwide, suggesting a global awareness of cosmic threats that transcends cultural boundaries. The builders of these monuments possess detailed knowledge of orbital mechanics, precession cycles, and celestial timing that allowed them to predict when dangerous objects might return. Such knowledge would be invaluable to any civilization that had witnessed cosmic catastrophe and understood the cyclical nature of celestial threats. The precision required for these astronomical calculations demands not only advanced mathematics, but also centuries of continuous observation. Pre-impact civilizations would need stable institutions capable of maintaining long-term research programs, tracking celestial objects across generations, and preserving accumulated knowledge through political and social changes. The sudden disruption of such institutions by cosmic bombardment would represent a catastrophic loss of scientific capability that might take millennia to restore. Evidence for this loss of astronomical knowledge appears in the historical record as a dark age of scientific understanding that lasted for thousands of years after the impact event. The sophisticated mathematical concepts embedded in megalithic sites do not reappear in documented form until the classical period, suggesting a gap in continuity that can only be explained by catastrophic disruption. What we interpret as the gradual development of astronomy and mathematics may actually be the slow rediscovery of knowledge that once existed in more advanced forms. The geographical distribution of megalithic sites follows patterns that make sense only in the context of post-catastrophe reconstruction. These monuments cluster in regions that would have offered the best survival prospects during the climate chaos that followed the impact event. Highland areas that remained above rising sea levels, river valleys that retained water sources during the extended drought, and locations with natural shelter from the extreme weather conditions that characterized the Younger Dryas period. The builders of these sites seem to have shared common knowledge despite being separated by vast distances and different cultures. The mathematical constants embedded in their monuments, the astronomical alignments that spanned continents, and the engineering techniques that required similar levels of sophistication all point to a shared intellectual heritage. This commonality suggests not independent development, but the preservation and transmission of pre-existing knowledge by survivor populations scattered across the globe. The deliberate burial of sites like Göbekli Tepe adds another layer to this interpretation. The decision to cover such an elaborate complex with tons of earth was not abandonment, but preservation, a conscious effort to protect the monuments from further damage while ensuring their survival for future discovery. The timing of this burial, approximately 8,000 years ago, coincides with another period of climate instability that may have threatened the survivor communities responsible for maintaining the site. Similar patterns of deliberate preservation appear at other megalithic locations, where structures were carefully covered or concealed rather than simply abandoned. The practice suggests that the builders understood their monuments contained information valuable enough to preserve, but fragile enough to require protection. They were creating time capsules encoded with knowledge that future civilizations might need, but might not be ready to understand immediately. Modern attempts to decode these ancient archives reveal layers of meaning that extend far beyond simple astronomical observations. The monuments encode information about Earth's geological cycles, climate patterns, and the orbital mechanics of potentially dangerous celestial objects. They preserve mathematical relationships that form the foundation of advanced engineering and architectural principles that ensure structural stability across millennia. Most importantly, they document the reality of cosmic threats and the devastating impact such events can have on human civilization. The consistency of this encoded information across different sites and cultures suggests a coordinated effort to preserve essential knowledge against future catastrophes. The builders were not working in isolation, but as part of a global network of survivor communities, sharing information and coordinating their preservation efforts. The monuments they created serve as nodes in this network, each containing pieces of a larger puzzle that becomes complete only when viewed as an integrated system. This perspective transforms the mystery of sites like Baalbek from engineering curiosities into crucial historical documents. The impossible precision of their construction, the astronomical knowledge embedded in their alignments, and the mathematical constants encoded in their proportions all serve as testimony to capabilities that once existed and evidence of the catastrophic events that nearly erased them from human memory. They stand as proof that our ancestors achieved far more than we have imagined and lost far more than we have remembered. The implications extend beyond archaeology into questions of cosmic security and the preparation for future threats. If the megalithic builders were documenting real astronomical dangers and preserving knowledge of past catastrophes, their monuments may contain warnings that remain relevant today. The Taurid meteor stream that they tracked so carefully continues to pose potential risks to Earth, with debris from the same source that may have caused the Younger Dryas event still orbiting through our planet's path. Modern space agencies have begun to acknowledge the reality of cosmic threats, establishing programs to track potentially hazardous asteroids and developing theoretical responses to impact scenarios. Yet the scale of preparation evident at ancient sites like the underground cities of Turkey suggests that our ancestors understood these threats more comprehensively than we do today. Their response was not theoretical but practical, involving massive construction projects designed to preserve human populations through extended periods of surface uninhabitability. The technological regression that followed the Younger Dryas impact demonstrates how quickly advanced capabilities can be lost when the social structures that support them are disrupted. The builders of Baalbek possessed engineering knowledge that allowed them to manipulate 1,000-ton blocks with precision that modern construction rarely achieves. Yet this capability vanished so completely that subsequent civilizations could only marvel at their achievements without understanding how they were accomplished. This pattern of technological loss and recovery may be more common in human history than we realize. The archaeological record shows repeated instances of sophisticated capabilities appearing suddenly, flourishing briefly, and then disappearing just as mysteriously. What we interpret as the linear progress of civilization may actually be a series of cycles, with each iteration building upon fragments preserved from earlier achievements, while struggling to restore what was lost to catastrophe. The Baalbek Stones stand as monuments to this cyclical nature of human development, proof that our capabilities have depths we have forgotten and heights we have yet to reclaim. They remind us that progress is not inevitable and that the knowledge we take for granted could vanish as completely as the techniques that shaped megalithic blocks with mathematical precision. In their silent testimony lies both warning and promise, evidence of human resilience and the eternal possibility of rediscovering what time and catastrophe have hidden from view. The weight of cosmic memory presses down through layers of sediment and stone, each stratum telling the same story in different tongues. Deep beneath the surface of our collective amnesia lie traces of knowledge systems so sophisticated they challenge every assumption about human development. The builders of Baalbek were not primitive peoples struggling with basic survival, but inheritors of intellectual traditions that spanned millennia of careful observation and mathematical refinement. Recent analysis of impact debris from the Younger Dryas boundary reveals a pattern of destruction so comprehensive that it rewrote the chemical composition of Earth's atmosphere. Microscopic diamonds formed under pressures that exist only in the hearts of explosions. Platinum concentrations spiked to levels found nowhere else in the geological record, and glass spherules scattered across continents bear the signature of temperatures exceeding those found in nuclear detonations. The planet itself became a laboratory for forces beyond terrestrial comprehension. What emerges from this forensic examination of ancient catastrophe is not merely confirmation of cosmic impact, but evidence of a bombardment so prolonged and devastating that it effectively reset the biological and cultural evolution of our species. The fragments that survive tell of civilizations sophisticated enough to predict such events, prepare for them, and preserve essential knowledge through the chaos that followed. The precision alignments found at megalithic sites worldwide represent not primitive sun worship, but advanced astronomical tracking systems designed to monitor the very cosmic debris fields that had already demonstrated their capacity for planetary devastation. The mathematical constants embedded within structures like Baalbek reveal knowledge of geometric relationships that would not be formally rediscovered until the classical period, thousands of years after these monuments were completed. The golden ratio appears in proportional relationships between massive stone blocks. Pi emerges from the angular measurements of megalithic alignments. Complex calculations involving Earth's dimensional properties are encoded in the placement and orientation of structures that supposedly predate the invention of advanced mathematics by millennia. This mathematical sophistication extends beyond simple geometric relationships into areas that require understanding of planetary mechanics and celestial timing. The builders demonstrated knowledge of precession, the slow wobble of Earth's rotational axis that takes 26,000 years to complete one cycle. They understood the relationship between Earth's orbital characteristics and the apparent movement of stars across the sky. Most remarkably, they possessed detailed information about the orbital periods of cometary debris that poses cyclical threats to planetary stability. Such knowledge could only be accumulated through generations of systematic observation, maintained by stable institutions capable of preserving and transmitting complex information across centuries. The sudden appearance of this astronomical sophistication in the archaeological record, followed by its equally sudden disappearance, suggests not gradual development, but the preservation of pre-existing knowledge by survivor populations working with inherited understanding they could not fully replicate. The engineering capabilities demonstrated at sites like Baalbek represent another dimension of this preserved knowledge. The precision required to quarry, transport, and place 1,000-ton blocks with millimeter accuracy demands understanding of structural mechanics, load distribution, and material properties that rivals modern engineering education. The tools and techniques necessary for such work require not only theoretical knowledge, but practical experience accumulated through generations of megalithic construction projects. Yet this engineering tradition appears suddenly in the archaeological record, achieves remarkable sophistication almost immediately, and then vanishes just as mysteriously as it emerged. The unfinished stones at Baalbek suggest that this disappearance was not gradual decline, but sudden interruption, as though the knowledge and capability to complete such projects simply ceased to exist. The precision of the abandoned blocks indicates that the work was nearly finished when it stopped, implying catastrophic disruption rather than voluntary abandonment. Underground complexes scattered throughout the impact region tell complementary stories of preparation and survival that illuminate the response of advanced populations to cosmic threats. These are not simple cave dwellings, but sophisticated engineering projects that require detailed knowledge of geology, hydrology, and structural mechanics. Multi-level cities capable of supporting thousands of inhabitants for extended periods demonstrate planning and coordination on scales that challenge conventional understanding of prehistoric organizational capabilities. The Derinkuyu complex alone contains evidence of engineering sophistication that includes precision carved ventilation systems, water management infrastructure, and defensive mechanisms designed to protect inhabitants from specific types of threats. The timing of construction and abandonment aligns precisely with periods of cosmic bombardment and subsequent recovery, suggesting these were not permanent settlements but emergency refuges designed for temporary occupation during surface uninhabitability. Archaeological investigation of these underground cities reveals construction techniques that mirror those found at megalithic surface sites. The same precision stonework, the same understanding of structural engineering principles, and the same mathematical relationships appear in subterranean architecture as in the great monuments above ground. The correlation suggests these were built by the same populations using the same inherited knowledge systems, representing both the defensive and memorial aspects of post-catastrophe reconstruction efforts. The global distribution of similar underground complexes follows patterns that make sense only when viewed as coordinated responses to planetary-scale threats. From the rock-cut churches of Lalibela to the extensive tunnel networks beneath European cities, evidence accumulates of systematic preparation for extended periods of surface danger. The scale and sophistication of these projects indicate populations with detailed understanding of the threats they faced and the timescales involved in cosmic bombardment cycles. Modern dating techniques applied to organic materials found within these complexes consistently return ages that cluster around the period immediately following the Younger Dryas impact event. Charcoal samples, bone fragments, and other organic debris preserved in sealed chambers provide calibrated radiocarbon dates that place major construction and occupation phases within centuries of the cosmic bombardment. The correlation is too consistent across too many sites to represent coincidence. The astronomical knowledge preserved in megalithic monuments gains deeper significance when viewed as disaster preparedness rather than religious devotion. The detailed tracking of meteor streams, the precise calculation of orbital periods for potentially dangerous objects, and the encoding of celestial mechanics in permanent stone structures all suggest populations that had witnessed cosmic catastrophe and understood the importance of monitoring future threats. This interpretation transforms sites like Göbekli Tepe from mysterious temples into sophisticated early warning systems. The astronomical alignments that researchers have identified encode information about the Taurid meteor stream, the same debris field associated with the Younger Dryas bombardment. The builders were not creating abstract art, but documenting specific observations of cosmic objects that had already demonstrated their capacity for planetary devastation. The deliberate burial of Göbekli Tepe approximately 8,000 years ago coincides with another period of increased cosmic activity, suggesting that the decision to cover the complex was made in response to renewed threats from space. The careful preservation of the structures beneath tons of earth indicates understanding that the information they contained would be valuable to future populations, even if immediate circumstances made maintaining the site too dangerous. Similar patterns of preservation and concealment appear at megalithic sites worldwide, where structures were carefully protected rather than simply abandoned. The practice suggests coordinated efforts to preserve essential knowledge through periods of instability, creating archives that could be rediscovered when conditions allowed. These were not random acts of construction, but systematic attempts to maintain continuity of knowledge across generations, separated by catastrophic disruption. The mathematical precision found in megalithic construction serves multiple purposes beyond simple structural integrity. The geometric relationships encoded in stone preserve information about Earth's dimensional properties, planetary mechanics, and the mathematical constants necessary for advanced engineering. These monuments function as three-dimensional textbooks, preserving essential knowledge in the most durable medium available to their builders. The consistency of these mathematical relationships across different sites and cultures indicates shared knowledge systems rather than independent development. The same geometric principles appear in monuments separated by thousands of miles and supposedly built by unrelated populations. The commonality suggests inheritance from a shared source rather than parallel evolution of complex mathematical understanding. Modern attempts to decode the information preserved in megalithic sites reveal layers of meaning that extend far beyond simple astronomical observations. The monuments contain encoded data about geological cycles, climate patterns, and the orbital mechanics of objects that pose potential threats to planetary stability. They preserve engineering principles that ensure structural longevity and mathematical relationships that form the foundation of advanced technological capabilities. The precision of this encoded information suggests that the builders possess knowledge systems comparable to modern scientific understanding in many areas. Their astronomical calculations demonstrate awareness of celestial mechanics, that was not formally rediscovered until the development of modern astronomy. Their engineering principles incorporate understanding of structural mechanics that rivals contemporary construction science. Their mathematical constants preserve relationships that form the basis of advanced physics and engineering. Yet this sophisticated knowledge appears suddenly in the archaeological record without apparent precursors, flourishes briefly during the period immediately following the cosmic impact event, and then disappears just as mysteriously. The pattern suggests not gradual development, but the preservation and gradual loss of pre-existing knowledge by populations struggling to maintain intellectual traditions through catastrophic disruption. The implications extend beyond archaeology into questions of knowledge preservation and the fragility of technological achievement. The capabilities demonstrated at sites like Baalbek represent the pinnacle of megalithic construction. Yet the techniques required to accomplish such feats vanish so completely that subsequent civilizations could only marvel at their achievements without understanding how they were created. This technological regression demonstrates how quickly advanced capabilities can be lost when the social structures that support them are disrupted. The specialization required for megalithic construction involves not only technical knowledge, but also the organizational capacity to coordinate large-scale projects across extended time periods. The breakdown of such coordination through catastrophic disruption would result in the rapid loss of capabilities that took generations to develop. The recovery of these lost technologies has been a slow process spanning millennia, with modern engineering only recently achieving the precision and scale demonstrated in ancient megalithic construction. The comparison suggests that human technological capability may be more cyclical than linear, with periods of advancement interrupted by catastrophic setbacks that force subsequent populations to rediscover knowledge that was once commonplace. The Baalbek Stones stand as testimony to this cyclical nature of human development. Monuments to capabilities that existed, were lost, and are only now being rediscovered. Their precision and scale serve as benchmarks for human achievement, proof that our ancestors accomplished feats that challenge our modern understanding of prehistoric capabilities. They remind us that progress is not inevitable and that knowledge once lost may take millennia to recover. In their silent testimony lies both warning and inspiration. Warning that the cosmic forces that disrupted ancient civilizations continue to pose threats to modern populations. Inspiration that human ingenuity and determination have repeatedly overcome seemingly impossible challenges, preserving essential knowledge through the darkest periods of disruption and loss. The story written in stone at Baalbek is not merely one of ancient achievement, but of human resilience in the face of cosmic catastrophe. The monuments preserve memory of both the heights of human capability and the depths of civilizational collapse, serving as permanent reminders of what we have accomplished and what we must be prepared to preserve against future threats. The revelation spreads like ripples across the archaeological community, each new discovery reinforcing a pattern that orthodox scholarship struggles to contain. Carbon dating of organic materials from impact sites reveals not one catastrophic moment, but waves of destruction spanning centuries, a prolonged bombardment that would have made recovery nearly impossible for any civilization caught in its path. The debris field from the fragmenting comet continued to rain destruction long after the initial impacts, creating an extended period of instability that lasted generations. At sites across the Middle East, archaeologists uncover layers of vitrified sand, glass formed by temperatures so extreme they could only result from atmospheric explosions. The distribution of these glass formations follows patterns consistent with airburst events, cosmic debris exploding in the atmosphere with force equivalent to nuclear weapons. The affected areas stretch from the Levant to Anatolia, encompassing the very regions where humanity's most mysterious megalithic sites would later emerge. Laboratory analysis of these vitrified materials reveals chemical signatures identical to those found in nuclear test sites, confirming temperatures exceeding 2,000 degrees Celsius. Such heat transforms ordinary sand into glass within seconds, creating distinctive mineral formations that serve as permanent markers of catastrophic events. The presence of these formations at multiple sites indicates not isolated incidents, but coordinated bombardment across vast geographical areas. The timing of this destruction aligns with disturbing precision to the abandonment patterns visible in the archaeological record. Settlement sites that had flourished for millennia show sudden termination layers, evidence of rapid abandonment followed by centuries of non-occupation. The break in cultural continuity is so complete that when human populations eventually return to these areas, they display entirely different tool traditions, architectural styles, and subsistence strategies. This cultural disruption extends beyond simple population displacement into fundamental changes in human social organization. Complex societies with evidence of specialized crafts, long-distance trade, and monumental architecture give way to scattered groups focused entirely on basic survival. The regression is so dramatic that it resembles the aftermath of nuclear war more than gradual cultural change, suggesting catastrophic disruption rather than evolutionary development. Yet within this devastation lie seeds of recovery that illuminate the true nature of megalithic construction. The sites where monuments like Baalbek eventually emerge are not random locations, but strategic positions chosen for their survival advantages during extended catastrophe. Highland areas that remained above fluctuating sea levels, regions with reliable water sources during climate chaos, and locations offering natural protection from extreme weather conditions. The builders who created these monuments possessed detailed knowledge of environmental cycles that allowed them to select sites capable of preserving their work through multiple catastrophic periods. Their understanding of geological stability, climate patterns, and natural disaster cycles demonstrates scientific sophistication that challenges every assumption about prehistoric intellectual capabilities. They were not building for their immediate needs, but for survival across geological timescales. This long-term perspective appears in every aspect of megalithic construction, from the selection of materials to the precision of placement. The stones chosen for monuments like Baalbek display properties that ensure maximum durability under extreme conditions. Limestone that resists weathering, granite that maintains structural integrity through seismic activity, and proportional relationships that distribute stress to prevent catastrophic failure during earthquakes or ground movement. The mathematical relationships embedded in these structures serve similar preservation functions, encoding essential information in forms that remain accessible even after the loss of written language or cultural memory. The geometric constants found in megalithic proportions preserve data about Earth's dimensional properties, celestial mechanics, and the mathematical principles necessary for advanced engineering. These monuments function as libraries without books, preserving knowledge in three-dimensional form. Modern reconstruction of ancient climate conditions reveals the full scope of environmental challenge that megalithic builders faced. The Younger Dryas period was not merely colder than previous eras, but chaotically unstable, with temperature swings of 10 degrees occurring within decades. Precipitation patterns shifted rapidly between extreme drought and devastating floods. Wind systems reorganized, creating dust storms that could bury entire landscapes within years. Under such conditions, any construction project would face extraordinary challenges. The logistics of quarrying and transporting massive stones become even more impossible when environmental conditions prevent reliable coordination of large workforces. Yet the precision of megalithic construction suggests not only that such projects were completed, but that they were executed with care and attention that exceeds most modern construction standards. This paradox resolves only when viewed through the lens of inherited knowledge rather than contemporary innovation. The builders possessed understanding accumulated over millennia of stable conditions, techniques refined through generations of experience with megalithic construction. When catastrophic disruption threatened to erase this knowledge permanently, survivor populations invested extraordinary effort in preserving what they could through monumental construction. The astronomical alignments found in megalithic sites take on deeper meaning when interpreted as disaster documentation rather than religious observation. The precise tracking of celestial objects, particularly meteor streams and cometary debris, represents early warning systems designed to predict when dangerous materials might return to Earth's vicinity. The builders had witnessed cosmic catastrophe and understood the cyclical nature of such threats. Modern analysis of the Taurid meteor stream, associated with both ancient impacts and ongoing cosmic debris, reveals orbital characteristics that bring potentially dangerous materials into Earth's path on predictable schedules. The astronomical knowledge preserved in sites like Göbekli Tepe and Baalbek includes detailed information about these orbital cycles, suggesting that ancient observers possessed understanding equivalent to modern space surveillance programs. The construction techniques required for megalithic monuments demonstrate capabilities that extend far beyond simple stone cutting and placement. The precision fitting of massive blocks requires understanding of material properties, thermal expansion coefficients, and structural load distribution that rivals modern engineering education. The tools necessary for such work must have been sophisticated beyond anything preserved in the archaeological record. Evidence for advanced tool technology appears in the tool marks left on megalithic blocks, which display characteristics consistent with precision machinery rather than hand tools. Spiral cutting patterns suggest rotary equipment operating at high speeds with diamond hard cutting surfaces. Straight line cuts extend for meters without deviation, indicating guided cutting systems with mechanical precision. Polish levels on stone surfaces match those achieved by modern grinding equipment using industrial abrasives. The disappearance of such capabilities represents one of archaeology's greatest mysteries. Technologies sophisticated enough to machine 1,000-ton blocks with millimeter precision simply vanish from the human toolkit, leaving no intermediate stages of decline or simplified versions of the original techniques. The break in continuity is so complete that it suggests catastrophic disruption rather than gradual abandonment. Underground preservation systems scattered throughout the impact region provide additional evidence of coordinated disaster response by populations with advanced planning capabilities. These are not simple shelters, but complex life support systems designed to maintain human communities through extended periods of surface uninhabitability. The engineering required for such projects demonstrates understanding of geology, hydrology, and environmental systems that rivals modern underground construction. The Cappadocia underground cities alone represent excavation of millions of cubic meters of solid rock, creating living spaces for tens of thousands of people across multiple levels. The precision of the rock cutting, the sophistication of the ventilation systems, and the integration of water management infrastructure indicate capabilities that challenge conventional understanding of prehistoric technology. These were not desperate emergency measures, but carefully planned preservation projects. Archaeological dating of these underground complexes reveals construction and occupation patterns that correlate precisely with cosmic bombardment cycles. Major excavation phases align with periods of increased impact activity, while abandonment patterns coincide with the return of stable surface conditions. The correlation suggests populations with detailed understanding of cosmic threat cycles and the timing necessary for underground survival. The global distribution of similar underground facilities indicates coordinated preparation for planetary-scale disasters. From the rock-cut monasteries of Ethiopia to the extensive tunnel networks beneath European cities, evidence accumulates of systematic preparation for extended periods of surface danger. The consistency of design principles and construction techniques across different continents suggests shared knowledge systems rather than independent development. Modern attempts to understand the full scope of these underground networks reveal connections between surface megalithic sites and subterranean preservation systems. Ground-penetrating radar surveys at locations like Baalbek detect extensive void networks beneath the visible monuments, suggesting that the surface structures represent only the visible portion of much larger complexes. The integration of surface and underground construction indicates comprehensive planning for multiple types of catastrophic scenarios. The astronomical knowledge preserved in megalithic alignments gains additional significance when viewed as components of integrated monitoring systems. The surface monuments track celestial objects, while underground facilities provide protection during dangerous periods. The combination represents a comprehensive approach to cosmic threat management that demonstrates sophisticated understanding of both observational astronomy and disaster preparedness. This interpretation transforms the mystery of megalithic construction from engineering curiosity into evidence of humanity's most ancient scientific tradition. The builders were not primitive peoples struggling with basic survival, but inheritors of knowledge systems that had been developed over thousands of years of careful observation and refinement. Their monuments preserve the culmination of prehistoric scientific achievement encoded in stone against the possibility of total civilizational collapse. The mathematical constants found in megalithic proportions serve multiple functions beyond simple structural design. The geometric relationships preserve information about planetary mechanics, celestial timing, and the physical constants necessary for advanced engineering. These monuments function as permanent archives, maintaining essential knowledge through periods when written records would be impossible to preserve. The precision of this encoded information suggests that prehistoric knowledge systems achieved levels of sophistication comparable to modern scientific understanding in many areas. The astronomical calculations demonstrate awareness of celestial mechanics that was not formally rediscovered until the development of telescopic astronomy. The engineering principles incorporate understanding of structural mechanics that rivals contemporary construction science. Yet this sophisticated knowledge appears suddenly in the archaeological record, flourishes during the period immediately following cosmic catastrophe, and then disappears just as mysteriously as it emerged. The pattern suggests not gradual development, but the preservation and gradual loss of pre-existing knowledge by populations working with inherited understanding they struggled to maintain through catastrophic disruption. The implications extend beyond archaeology into questions of knowledge, preservation, and technological continuity. The capabilities demonstrated at sites like Baalbek represent achievements that modern civilization has only recently begun to match. Yet they were accomplished by populations working without the industrial infrastructure we consider essential for such projects. The comparison suggests that human ingenuity may be capable of far more than our current technological paradigms assume possible. The story preserved in stone at Baalbek is ultimately one of human determination in the face of cosmic forces beyond earthly comprehension. The monuments stand as testimony to populations that witnessed planetary catastrophe and chose to preserve what they could of their knowledge and capabilities for future generations. Their precision and permanence serve as messages across time, proof that human achievement can survive even the most devastating disruption. In the end, the mystery of the Baalbek Stones may not be how they were built, but why their builders understood the importance of building them at all. If they represent archives of pre-catastrophe knowledge preserved against future disasters, then they serve as both memorial and warning, evidence of what human civilization can achieve and what it must be prepared to lose. The stones remember what we have forgotten, waiting in patient silence for the day we might remember how to read their message. The darkness beneath our feet holds more secrets than the light above reveals. Advanced ground-penetrating radar surveys conducted across the Baalbek complex in recent years have detected extensive void networks stretching far beyond the visible monuments. suggesting that what we see on the surface represents merely the exposed tip of a vast underground architecture. These subterranean chambers and passages extend in geometric patterns that mirror the mathematical precision found in the surface megaliths, indicating coordinated construction across both vertical and horizontal dimensions. The radar signatures reveal rectangular voids arranged in systematic grids, circular chambers connected by straight tunnels, and vertical shafts that descend to depths where current technology cannot penetrate. The geometric regularity of these underground features rules out natural formation, while their integration with surface monuments suggests they were components of a unified architectural vision. The builders of Baalbek were not merely placing massive stones on bedrock, but creating a three-dimensional complex that extended deep into the earth itself. Seismic surveys have identified anomalous resonance patterns beneath the trilithon, indicating large, hollow spaces that amplify sound waves in ways consistent with engineered acoustic chambers. When researchers generate low-frequency tones at the surface, the underground voids produce harmonic responses that suggest sophisticated understanding of acoustic engineering. The entire complex appears designed to function as a massive resonance system and, with surface-subsurface components working together to amplify and focus vibrational energy. This acoustic sophistication extends beyond simple sound amplification into areas that challenge our understanding of ancient technological capabilities. Frequency analysis reveals that the underground chambers resonate at specific wavelengths that correspond to naturally occurring electromagnetic frequencies in Earth's atmosphere. The builders somehow understood relationships between sound, vibration, and electromagnetic energy that modern science has only recently begun to explore. Archaeological excavations in accessible portions of the underground network have uncovered construction techniques identical to those used in the surface megaliths. The same precision stone cutting, the same impossible fitting tolerances, and the same mathematical proportions appear in subterranean architecture as in the monuments above ground. The consistency suggests these were not separate projects, but integrated phases of a comprehensive construction program executed according to unified design principles. Carbon dating of organic materials found within sealed underground chambers consistently returns ages that predate the Roman occupation by thousands of years, confirming that the subterranean construction belongs to the same mysterious megalithic period as the surface monuments. Charcoal fragments, bone tools, and other organic debris preserve evidence of the original builders, though their identity remains as enigmatic as their capabilities. The discovery of advanced drainage systems within the underground network reveals understanding of hydrology that rivals modern engineering. Precision-cut channels direct groundwater flow with mathematical efficiency, preventing flooding while maintaining stable humidity levels throughout the complex. The system demonstrates knowledge of geological water patterns, seasonal flow variations, and the engineering principles necessary to manage large-scale underground water resources. Most remarkably, the drainage channels incorporate features that suggest they were designed to function during catastrophic flooding events. Overflow systems, emergency bypasses, and structural reinforcements indicate preparation for water levels far exceeding normal seasonal variations. The builders anticipated environmental conditions so extreme that they engineered their underground systems to survive submersion under hundreds of feet of water. This flood preparation takes on new significance when viewed alongside geological evidence for catastrophic water events in the region's history. Sediment analysis reveals multiple layers of rapid deposition consistent with massive flooding episodes, some depositing meters of material within short time periods. The timing of these flood layers correlates with periods of cosmic bombardment, suggesting that the underground flood defenses were responses to water displacement caused by impact events. The integration of flood protection with acoustic engineering reveals a level of systems thinking that challenges every assumption about prehistoric planning capabilities. The builders understood that their underground chambers needed to function both as resonant acoustic spaces and as survival shelters during catastrophic flooding. The engineering solutions they developed serve both purposes without compromising either function, demonstrating mastery of multiple technical disciplines working in harmony. Recent electromagnetic surveys have detected metallic anomalies within the underground structure that suggest the presence of materials not found in typical limestone construction. Magnetometer readings indicate concentrations of iron or other ferrous materials arranged in geometric patterns that mirror the surface monument alignments. The metallic components appear to be integrated into the stone construction rather than added later, suggesting they were part of the original design. These metallic elements may explain the unusual electromagnetic properties that researchers have documented at Baalbek. Sensitive instruments detect fluctuating magnetic fields that vary with solar activity, atmospheric conditions, and even lunar cycles. The complex appears to respond to cosmic electromagnetic phenomena in ways that suggest it was designed to interact with energy fields beyond simple structural requirements. The astronomical alignments found in the surface monuments extend into the underground network, where passages and chambers orient towards celestial objects. With the same precision found above ground, vertical shafts align with pole stars, horizontal tunnels point toward solstice positions, and circular chambers focus on specific constellations. The builders created a three-dimensional astronomical instrument that tracks celestial mechanics from multiple perspectives simultaneously. This comprehensive astronomical monitoring system would have provided unprecedented precision in tracking cosmic objects, particularly those that posed potential impact threats. The underground chambers could function as protected observatories, allowing continuous celestial surveillance even during surface environmental disasters. The integration of observation and protection represents strategic thinking about long-term cosmic threat management. Modern attempts to map the full extent of the underground network have been hampered by official restrictions and the technical challenges of surveying deep rock formations. Government authorities limit access to certain areas, citing structural preservation concerns, while the limestone geology interferes with some remote sensing technologies. What has been documented suggests a complex far larger and more sophisticated than anything visible on the surface. The implications of this hidden architecture transform our understanding of Baalbek from impressive Roman temple site to remnant of prehistoric technological achievement. The surface monuments represent only the visible portion of a comprehensive engineering project that integrated astronomy, acoustics, hydrology, and structural mechanics into a unified system designed to function across geological timescales. The mathematical relationships preserved in the underground geometry encode the same constants found in surface monuments, confirming that both levels were designed according to identical principles. The golden ratio appears in chamber proportions. Pi emerges from tunnel curvatures, and complex geometric relationships preserve information about Earth's dimensional properties and celestial mechanics. The entire complex functions as a three-dimensional archive of mathematical and astronomical knowledge. The precision of underground construction matches that found in surface megaliths, with stone blocks fitted to tolerances measured in fractions of millimeters. Tool marks on underground surfaces display the same spiral cutting patterns and mechanical precision found on exterior monuments, confirming that the same advanced techniques were used throughout the complex. The consistency suggests coordinated construction by populations with standardized tools and methods. Archaeological evidence from the underground network includes artifacts that challenge conventional understanding of prehistoric technology. Stone tools display wear patterns consistent with cutting materials much harder than limestone, while metal fragments show alloy compositions that require sophisticated metallurgical knowledge. The artifact assemblage suggests technological capabilities far beyond those attributed to Bronze Age populations. The discovery of organic materials preserved in sealed underground chambers provides unprecedented insight into the environmental conditions during construction. Pollen analysis reveals plant species that no longer exist in the region, indicating climate conditions significantly different from those recorded in historical times. The preserved organic material suggests the builders lived during a period of environmental abundance that ended abruptly and permanently. Isotopic analysis of these preserved materials reveals chemical signatures consistent with cosmic bombardment events, including elevated levels of rare earth elements and isotopic ratios that match impact debris found at other Younger Dryas boundary sites. The correlation confirms that the Baalbek builders lived through or immediately after the cosmic catastrophe that marked the end of the last ice age. The underground preservation systems at Baalbek represent the most sophisticated disaster preparation facilities yet discovered from prehistoric times. The engineering required to excavate millions of cubic feet of solid limestone, create stable multi-level spaces, and integrate complex life support systems demonstrates capabilities that rival modern underground construction projects. The builders possessed knowledge of geology, structural mechanics, and environmental systems that allowed them to create spaces capable of supporting large populations through extended catastrophic periods. The acoustic properties of these underground chambers suggest they serve purposes beyond simple shelter, functioning as spaces designed to enhance human consciousness through controlled sound environments. The resin wave patterns associated with altered states of awareness and frequencies generated within the chambers correspond to brain between sound, vibration, and human, suggesting the builders understood relationships, neural activity. This combination of practical disaster preparation with consciousness-altering acoustic design reveals the sophisticated understanding that prehistoric builders possessed about human survival on multiple levels. They recognized that preserving physical life required not only protection from environmental threats, but also maintenance of psychological and spiritual well-being through extended periods of underground isolation. The global distribution of similar underground complexes indicates that the Baalbek network was part of a worldwide system of preservation facilities, created by populations sharing common knowledge and responding to planetary-scale threats. From the Cappadocia cities to the Maltese hypogeum, evidence accumulates of coordinated underground construction using consistent design principles and construction techniques. The timing of construction and abandonment across these sites correlates with cosmic bombardment cycles, suggesting that prehistoric populations possess detailed understanding of celestial threat patterns and the timing necessary for underground survival. The builders were not responding to isolated disasters, but to recurring cosmic events that pose cyclical dangers to surface civilization. Modern investigation of the Baalbek underground network continues to reveal new chambers and passages, each discovery expanding our understanding of the complex's true scope and sophistication. Ground-penetrating radar surveys detect additional voids at depths that exceed current excavation capabilities, suggesting that the deepest levels of the complex remain unexplored and may contain preservation systems designed for the most extreme catastrophic scenarios. The mathematical precision found throughout the underground construction serves multiple functions beyond structural integrity, encoding information about geological cycles, astronomical mechanics, and the physical constants necessary for advanced engineering. These subterranean chambers function as permanent archives, preserving essential knowledge in three-dimensional form against the possibility of complete civilizational collapse. The integration of surface monuments with underground preservation systems represents humanity's most ancient and sophisticated approach to disaster preparedness. The builders understood that surviving cosmic catastrophe required not only immediate protection, but also long-term preservation of knowledge and capabilities necessary for civilizational recovery. Their comprehensive approach to threat management demonstrates strategic thinking that extends across multiple generations and geological timescales. In the darkness beneath Baalbek lies testament to human foresight and determination in the face of cosmic forces beyond earthly comprehension. The underground chambers preserve not only physical spaces for survival, but also the intellectual heritage necessary for rebuilding civilization after catastrophic disruption. Their precision and permanence serve as messages across time, proof that human planning and engineering can create systems capable of preserving essential knowledge through the most devastating circumstances. The story written in stone and carved in darkness beneath Baalbek is ultimately one of preparation and preservation, evidence of populations that understood both the reality of cosmic threats and the importance of maintaining continuity of knowledge across catastrophic boundaries. Their underground archives wait in patient silence, preserving the memory of capabilities and understanding that challenge every assumption about prehistoric human achievement. The silence of stone carries its own language, one that speaks not in words, but in the weight of impossibility made manifest. When researchers finally gained access to sealed sections of the underground network in 2019, their instruments registered something that defied conventional explanation. Temperature readings within the deepest chambers remained constant regardless of surface conditions, maintaining precise thermal equilibrium that suggested active regulation rather than passive insulation. The limestone itself seemed to breathe, expanding and contracting in rhythmic patterns that matched no known geological process. Electromagnetic monitoring equipment deployed within these chambers detected field fluctuations that correlated with solar activity occurring 93 million miles away. The underground spaces responded to cosmic events in real time, as though the entire complex functioned as a planetary antenna tuned to frequencies beyond human perception. When solar flares erupted on the sun's surface, sensitive instruments recorded corresponding energy spikes deep beneath the Baalbek Plateau, suggesting that the builders had created a structure capable of detecting and perhaps channeling celestial forces. The precision of this cosmic sensitivity becomes even more remarkable when viewed alongside recent discoveries in adjacent chambers. Crystalline formations found embedded within the limestone walls display geometric patterns that occur nowhere else in natural geology. These are not random mineral deposits, but carefully arranged structures that exhibit properties associated with piezoelectric materials. When subjected to pressure or vibration, they generate measurable electrical charges that vary according to the frequency and intensity of applied force. Laboratory analysis reveals that these crystal formations contain trace elements that do not occur naturally in regional limestone deposits. Rare earth metals, isotopic variations, and molecular structures that require extreme pressures to form all point toward artificial enhancement of natural geological processes. The builders possessed knowledge of material science that allowed them to modify stone at the atomic level, creating hybrid materials with properties that bridge the gap between natural minerals and engineered composites. The implications extend far beyond simple construction techniques into realms that challenge our understanding of prehistoric technological capabilities. The ability to manipulate matter at the molecular level requires not only theoretical knowledge of atomic structure, but also practical methods for implementing such modifications on a massive scale. The underground chambers contain millions of tons of enhanced limestone, suggesting industrial processes capable of transforming entire geological formations. Evidence for such processes appears in isotopic analysis of core samples taken from different depths within the complex. Ratios of carbon, oxygen, and calcium isotopes vary in patterns that correlate with distance from central chambers, indicating that enhancement effects radiated outward from specific focal points. The distribution suggests the builders used concentrated energy sources to modify limestone properties across vast volumes of stone, creating graduated zones of enhanced material characteristics. The energy requirements for such modifications exceed anything achievable through conventional means, pointing toward technologies that harnessed forces beyond mechanical or chemical processes. Recent quantum physics research has demonstrated that matter can be altered through resonant frequency manipulation, using specific wavelengths to modify molecular bonds and atomic arrangements. The acoustic properties documented throughout the Baalbek complex suggest that the builders may have developed practical applications of such principles thousands of years before modern science rediscovered them. This interpretation gained support from analysis of harmonic patterns recorded within the underground chambers. Frequency measurements reveal standing wave formations that create zones of intensified vibrational energy at precise geometric locations. These energy concentration points correspond exactly with areas where the most dramatic limestone modifications occur, suggesting that acoustic focusing was used to direct transformative forces with surgical precision. The mathematical relationships governing these harmonic patterns encode information about wave mechanics and resonant frequency calculations that would not be formally understood until the development of modern acoustics. The builders demonstrated practical mastery of vibrational physics that allowed them to predict and control energy distribution within complex three-dimensional spaces. Their acoustic engineering surpasses many contemporary achievements in sound design and architectural acoustics. Recent discoveries in quantum archaeology, a field that applies particle physics principles to archaeological investigation, have detected subatomic signatures within the enhanced limestone that match those found in materials exposed to controlled fusion reactions. The isotopic fingerprints suggest that the builders possessed energy sources capable of generating temperatures and pressures comparable to those found in stellar cores, allowing them to modify matter through processes that mirror natural stellar nucleosynthesis. Such capabilities would explain not only the enhanced limestone properties, but also the precision stone cutting techniques evident throughout the complex. If the builders could manipulate matter at the atomic level, conventional concepts of quarrying and shaping become obsolete. Instead of cutting stone, they may have been restructuring it, rearranging molecular bonds to achieve desired shapes and properties without the mechanical stress associated with traditional stoneworking. This perspective transforms our understanding of megalithic construction from impressive engineering achievement to evidence of mastery over fundamental forces of nature. The precision fitting of massive blocks results not from superior measuring tools, but from the ability to modify stone properties to achieve perfect conformance. The impossible tolerances documented at Baalbek become possible when viewed as products of matter manipulation rather than mechanical machining. The energy sources required for such processes remain enigmatic, though clues appear in the electromagnetic properties documented throughout the complex. The correlation between underground energy fields and cosmic events suggests that the builders developed methods for capturing and storing celestial energy, possibly through resonant coupling with planetary and solar electromagnetic phenomena. The entire complex may have functioned as a massive energy collection and concentration system. Evidence for energy storage appears in the form of crystalline matrices found within the deepest chambers, formations that exhibit properties associated with supercapacitor technology. These natural batteries could theoretically store vast amounts of electrical energy for extended periods, providing power reserves adequate for matter manipulation processes even during periods of reduced cosmic energy availability. The builders may have created a self-sustaining technological system that remained operational across geological timescales. The global implications of such technology become apparent when similar underground complexes are examined for comparable energy signatures. Initial surveys at sites including Cappadocia, Malta, and various European locations detect electromagnetic anomalies consistent with the Baalbek findings. The distribution suggests a worldwide network of energy-based technological facilities, all operating according to similar principles and possibly interconnected through planetary electromagnetic systems. This technological network would explain the consistency of construction techniques and mathematical relationships found at megalithic sites worldwide. Rather than independent development of similar capabilities, the evidence points toward a unified technological system that operated on a planetary scale. The builders possessed not only advanced individual technologies, but also the organizational capacity to coordinate their implementation across continents. The timing of this technological deployment correlates precisely with the period immediately following the Younger Dryas impact event, suggesting that advanced energy manipulation capabilities were developed as part of recovery efforts after cosmic catastrophe. The builders may have been forced to develop technologies capable of rebuilding civilization using resources and methods that could function in a post-catastrophe environment, characterized by climatic instability and disrupted natural systems. Archaeological evidence from this period shows dramatic technological advancement occurring within centuries of the impact event, a pace of development that challenges conventional understanding of how technological progress occurs. The rapid deployment of megalithic construction techniques, advanced astronomy, and sophisticated engineering suggests access to preserved knowledge rather than gradual innovation. The builders were implementing pre-existing technological concepts rather than developing new ones through trial and error. The preservation of such knowledge through cosmic catastrophe would require storage systems capable of surviving planetary-scale disasters. The underground chambers at Baalbek and similar sites may have functioned as technological archives, preserving not only theoretical knowledge but also the practical tools and energy systems necessary for implementation. The enhanced limestone properties could represent a form of data storage, with molecular modifications encoding information in permanent form. This interpretation transforms the mystery of megalithic construction into evidence of humanity's most sophisticated disaster recovery program. The builders were not primitive people struggling with basic survival, but inheritors of advanced technological traditions who possessed both the knowledge and capability to rebuild civilization using methods that could function under post-catastrophe conditions. Their achievements represent not the beginning of human technological development, but its recovery and preservation after near-total disruption. The mathematical constants encoded throughout these facilities serve multiple functions beyond simple structural design, preserving information about energy manipulation techniques, matter modification processes, and the physical relationships necessary for advanced technological applications. These monuments function as permanent technical manuals, maintaining essential knowledge in forms that remain accessible even after the loss of conventional information storage systems. Modern attempts to decode this preserved information reveal layers of meaning that extend from basic engineering principles to advanced applications of quantum physics. The geometric relationships found in megalithic construction encode formulae for energy concentration, frequency manipulation, and matter restructuring that represent practical applications of theoretical physics concepts. The builders possessed understanding of fundamental forces that modern science is only beginning to explore. The precision of this encoded information suggests that prehistoric technological systems achieve levels of sophistication that exceed current human capabilities in many areas. The energy manipulation techniques implied by the enhanced limestone modifications represent mastery of quantum processes that contemporary technology cannot replicate. The acoustic engineering principles demonstrate understanding of wave mechanics that surpasses modern acoustics research. Yet this sophisticated technology appears suddenly in the archaeological record, operates for a limited period following cosmic catastrophe, and then disappears just as mysteriously as it emerged. The pattern suggests not gradual technological development, but the preservation and gradual loss of pre-existing capabilities by populations working with inherited knowledge they struggled to maintain through catastrophic disruption. The implications extend beyond archaeology into questions of technological continuity and the preservation of advanced knowledge across catastrophic boundaries. The capabilities demonstrated at sites like Baalbek represent achievements that modern civilization has yet to match, accomplished by populations working without the industrial infrastructure we consider essential for advanced technology. The comparison suggests that human technological potential may extend far beyond current paradigms, limited more by conceptual frameworks than by practical possibilities. The story preserved in stone and energy at Baalbek is ultimately one of technological resilience in the face of cosmic forces that dwarf human comprehension. The facilities represent humanity's most ambitious attempt to preserve advanced capabilities through catastrophic disruption, creating systems designed to maintain technological continuity across geological timescales. Their precision and permanence serve as testimony to human ingenuity operating at the intersection of science and survival. In the enhanced limestone and crystalline matrices beneath Baalbek lies evidence of technological mastery that challenges every assumption about prehistoric human capabilities. The facilities preserve not only advanced engineering techniques, but also the energy systems and matter manipulation technologies that made such achievements possible. Their electromagnetic signatures continue to pulse through bedrock, maintaining technological archives that wait for the day humanity might rediscover how to access their preserved knowledge. The mystery of the Baalbek Stones extends beyond questions of construction into realms of technological possibility that span from ancient achievement to future potential. The evidence suggests that human civilization has achieved far greater heights than historical records indicate, and that the knowledge necessary for such achievements may still exist, encoded in stone and energy, waiting for minds capable of recognizing and implementing its preserved wisdom. The threads of evidence converge like electromagnetic field lines, drawing together disparate discoveries into patterns that demand recognition. Across the globe, researchers working in isolation have begun reporting identical anomalies at megalithic sites separated by thousands of miles and supposedly thousands of years. Ground-penetrating radar surveys at Göbekli Tepe reveal underground chambers with the same geometric precision found beneath Baalbek. Electromagnetic measurements at Stonehenge detect field fluctuations that mirror those recorded in Lebanon. The mathematical constants embedded in Egyptian pyramid construction appear with identical precision in Cambodian temple complexes and Peruvian mountain fortresses. What emerges from this convergence is not coincidence, but coordination. The consistency of technological signatures across continents suggests a unified knowledge system that operated on a planetary scale. The builders of these monuments were not isolated populations struggling independently with similar challenges, but components of a global network that shared advanced understanding of energy manipulation, matter modification, and cosmic threat assessment. Their achievements represent not parallel evolution, but coordinated implementation of common technological principles. Archaeological dating of organic materials from these sites consistently returns ages that cluster around specific periods of cosmic instability, particularly the aftermath of impact events that left distinctive signatures in Earth's geological record. The correlation suggests that advanced technological deployment occurred in response to planetary-scale disasters, with survivor populations implementing preserved knowledge to create systems capable of maintaining civilizational continuity through extended periods of environmental chaos. The scope of this technological network becomes apparent when quantum archaeological techniques are applied to megalithic sites worldwide. Subatomic analysis reveals isotopic signatures that match those found in materials exposed to controlled nuclear processes, suggesting that matter manipulation technologies were standard components of prehistoric construction techniques. The enhanced material properties found in megalithic blocks from every continent indicate systematic application of atomic-level modification processes that exceed current human capabilities. Recent discoveries at underwater sites add another dimension to this global technological system. Sonar mapping of submerged structures off the coasts of India, Japan, and the Mediterranean reveals construction techniques identical to those found at surface megalithic sites. Carbon dating of organic materials trapped within these underwater monuments indicates construction periods that predate the post-glacial sea level rise, suggesting that the technological network operated when current coastal areas were dry land. The submersion of these sites during rapid sea level changes associated with Ice Age termination would have disrupted the global network, severing connections between distant facilities and forcing isolated populations to maintain technological systems without coordinated support. Archaeological evidence from the period immediately following major sea level rise shows dramatic technological regression at sites worldwide, with sophisticated construction techniques giving way to cruder methods within centuries of network disruption. This pattern of technological decline following network disruption illuminates the fragility of advanced systems that depend on coordinated maintenance and knowledge sharing. The capabilities demonstrated at megalithic sites required not only theoretical understanding, but also practical expertise maintained through continuous application. When cosmic catastrophe disrupted the social structures that supported such expertise, even the most sophisticated technologies could be lost within generations. The mathematical relationships preserved in megalithic construction take on new significance when viewed as components of a distributed information system. The geometric constants found at each site encode specific datasets that, when combined with information from other network nodes, form comprehensive archives of technological knowledge. Individual monuments function as components in a global library, each preserving essential information while contributing to a larger knowledge preservation system. Modern cryptographic analysis of these mathematical relationships reveals layers of encoded information that extend far beyond simple architectural proportions. The geometric patterns preserve formulae for energy concentration, frequency manipulation, and matter modification that represent practical applications of advanced physics principles. The precision of this encoded data suggests that the builders possessed understanding of quantum mechanics, electromagnetic field theory, and nuclear processes that modern science is only beginning to develop. The acoustic properties documented at megalithic sites worldwide display consistent characteristics that suggest coordinated tuning of the global network for electromagnetic resonance. Each facility appears calibrated to specific frequencies that, when activated simultaneously, would create standing wave patterns capable of encompassing the entire planet. The builders may have created a global resonance system capable of detecting and responding to cosmic threats through coordinated electromagnetic monitoring. Evidence for such coordination appears in the form of crystalline matrices found within megalithic structures at sites spanning every continent. These formations exhibit properties associated with quantum entanglement, maintaining correlated states across vast distances that would allow instantaneous communication between network nodes. The builders possessed understanding of quantum physics principles that enabled them to create communication systems operating faster than light speed limitations. Archaeological investigation of these crystalline communication systems reveals activation patterns that correlate with periods of increased cosmic activity. The network appears to have operated most intensively during times when Earth faced elevated risks from asteroid impacts, solar storms, or other celestial threats. The builders created not merely monuments but components of a planetary early warning system capable of coordinating global responses to cosmic dangers. The energy requirements for such a system would have been enormous, demanding power sources capable of generating and maintaining electromagnetic fields on planetary scales. Evidence for such energy systems appears in the form of enhanced geological formations found beneath megalithic sites worldwide. Isotopic analysis reveals mineral compositions that could only result from exposure to intense energy fields, suggesting that the builders developed methods for tapping into planetary electromagnetic systems. Geological surveys detect anomalous magnetic field concentrations at megalithic sites that persist across geological timescales, indicating permanent modifications to Earth's electromagnetic structure. The builders may have created artificial magnetic field generators that continue to operate thousands of years after their construction, drawing energy from planetary rotation and solar electromagnetic interaction. These systems represent technological achievements that exceed current human understanding of large-scale energy manipulation. The precision required for such planetary-scale engineering demonstrates mastery of systems thinking that integrates multiple scientific disciplines into unified technological applications. The builders possessed understanding of geology, astronomy, electromagnetics, quantum physics, and material science that allowed them to create integrated systems operating across multiple scales simultaneously. Their achievements represent not isolated technical innovations, but comprehensive technological paradigms that modern science is only beginning to glimpse. Modern investigation of these technological systems faces restrictions imposed by governmental and academic institutions that limit access to critical data and prevent comprehensive analysis of the evidence. Official explanations continue to attribute megalithic achievements to conventional construction techniques, despite mounting evidence that such methods could not have produced the documented results. The resistance to acknowledging advanced prehistoric technology suggests institutional investment in maintaining conventional historical narratives regardless of contradictory evidence. Independent researchers working outside official channels have begun documenting technological signatures that reveal the true scope of prehistoric achievements. Electromagnetic measurements, quantum archaeological analysis, and materials science investigations consistently point toward capabilities that challenge fundamental assumptions about human technological development. The evidence suggests that current civilization represents not the pinnacle of human achievement, but a recovery phase following catastrophic disruption of far more advanced systems. The implications extend beyond archaeology into questions of human potential and technological possibility. If prehistoric populations achieve mastery over fundamental forces of nature, then current technological limitations may reflect conceptual rather than practical constraints. The builders of megalithic monuments demonstrated that human consciousness and ingenuity can develop solutions to challenges that exceed the scope of conventional engineering approaches. The mathematical precision found throughout the global megalithic network preserves information about technological principles that could revolutionize modern science and engineering. The geometric relationships encode formulae for energy manipulation techniques that could provide solutions to current environmental and resource challenges. The acoustic engineering principles demonstrate methods for consciousness enhancement that could accelerate human intellectual and spiritual development. Yet this preserved knowledge remains largely inaccessible to populations that lack the conceptual frameworks necessary for recognizing and implementing its applications. The builders encoded their understanding in forms that require advanced mathematical and scientific literacy to decode, creating archives that reveal their secrets only to minds prepared to understand their implications. Modern civilization must develop sufficient intellectual sophistication to deserve access to such powerful knowledge. The global network of megalithic sites continues to operate according to principles established thousands of years ago, maintaining electromagnetic signatures and quantum entanglement states that preserve connections across continents. Sensitive instruments can still detect coordinated responses to cosmic events at sites worldwide, suggesting that the ancient warning system remains partially functional despite millennia of neglect and technological regression. The reactivation of this network may be possible through coordinated application of modern technology, combined with understanding of the original design principles. Recent experiments in electromagnetic field manipulation have produced resonance effects that mirror those documented at megalithic sites, suggesting that contemporary science is approaching the theoretical understanding necessary for comprehending prehistoric technological achievements. The timing of such rediscovery becomes critical as Earth faces increasing risks from cosmic threats that the ancient network was designed to monitor and counter. Solar activity continues to intensify. Asteroid detection programs identify growing numbers of potentially hazardous objects, and climate systems show signs of instability that echo patterns associated with past catastrophic disruptions. The knowledge preserved in megalithic monuments may prove essential for navigating challenges that threaten current civilization. The builders of Baalbek and similar sites around the world were not primitive people struggling with basic survival, but representatives of humanity's highest technological achievement, working to preserve essential knowledge through catastrophic disruption. Their monuments stand as testimony to human capability and cosmic vulnerability in equal measure, reminding us that progress is not inevitable and that the greatest achievements can vanish as completely as they once emerged from seemingly impossible circumstances. In the enhanced limestone and crystalline matrices that pulse with ancient energy beneath megalithic sites, worldwide lies humanity's most sophisticated technological heritage, waiting for minds capable of recognizing its significance and implementing its preserved wisdom. The mystery of the Baalbek Stones ultimately points not backward toward lost civilizations, but forward toward human potential that remains largely untapped, encoded in stone and energy for the day when consciousness evolves sufficiently to reclaim its technological birthright. The cosmic forces that once threatened to erase human achievement continue to orbit through space, following predictable cycles that the ancient builders tracked with mathematical precision. Their monuments serve as both memorial and manual, preserving memory of past catastrophes, while encoding the knowledge necessary for surviving future challenges. In their silent testimony lies humanity's greatest lesson about the relationship between consciousness, technology, and cosmic responsibility, waiting for the moment when we become worthy of rediscovering what we once knew and might yet know again. The revelation spreads like wildfire through underground research networks, each new measurement confirming what orthodox archaeology refuses to acknowledge. At megalithic sites across the planet, instruments register identical electromagnetic pulses that synchronize with solar radiation cycles, as though ancient builders had woven their monuments into the very fabric of cosmic rhythms. When solar storms erupt 93 million miles away, sensitive equipment detects corresponding energy fluctuations deep beneath Lebanese limestone, Egyptian granite, and Peruvian andesite with precision that defies coincidence. The implications cascade through every assumption we hold about prehistoric capability. If these monuments truly function as planetary-scale instruments, then their builders possessed understanding of electromagnetic theory that would not be formally rediscovered until Maxwell's equations in the 19th century. Yet here, encoded in stone alignments and crystalline matrices, lies practical application of field theory principles that modern physics struggles to implement on such vast scales. Recent analysis of mineral compositions within megalithic blocks reveals isotopic signatures that occur nowhere else in natural geology. Trace elements display ratios consistent with controlled nuclear processes, while crystal lattice structures show modifications possible only under extreme electromagnetic conditions. The evidence points toward matter manipulation technologies that operated at the atomic level, transforming ordinary stone into engineered materials with properties that bridge the gap between natural minerals and synthetic composites. Laboratory examination of these enhanced materials produces results that challenge every textbook explanation of ancient construction methods. Microscopic analysis reveals molecular arrangements that require pressures exceeding those found in Earth's core, temperatures comparable to stellar fusion reactions, and electromagnetic fields strong enough to restructure atomic bonds. The builders possessed energy sources and manipulation techniques that allowed them to modify matter with precision that rivals modern nanotechnology. The mathematical relationships governing these modifications follow patterns that encode information about quantum field interactions, electromagnetic resonance frequencies, and the physical constants necessary for atomic restructuring. Each megalithic site preserves specific data sets that, when combined with information from other network locations, form comprehensive archives of technological knowledge spanning multiple scientific disciplines. The monuments function as permanent libraries, maintaining essential information in three-dimensional mathematical form. The acoustic properties documented throughout this global network display characteristics that suggest coordinated tuning for electromagnetic amplification. Sound waves generated at individual sites create standing wave patterns that propagate through bedrock and interact with similar patterns from distant monuments. When multiple sites activate simultaneously, the resulting interference patterns encompass entire continents, creating electromagnetic resonance fields capable of detecting subtle changes in planetary energy systems. Evidence for such coordinated operation appears in historical accounts of mysterious phenomena associated with megalithic sites during periods of celestial activity. Ancient texts describe stones that hum during eclipses, monuments that glowed during meteor showers, and architectural features that resonated with sounds that seemed to originate from the Earth itself. These accounts, dismissed as mythology by conventional scholarship, gain new credibility when viewed as documentation of technological systems responding to cosmic events. Modern investigation of these phenomena faces systematic obstruction from institutions that control access to megalithic sites and limit research applications that might reveal their true nature. Official archaeological policies restrict electromagnetic measurements, prohibit deep geological surveys, and prevent the installation of monitoring equipment that could document ongoing energy fluctuations. The resistance suggests institutional awareness of discoveries that would fundamentally alter our understanding of human technological history. Independent researchers working outside official channels have documented energy signatures that confirm the operation of planetary-scale technological systems throughout prehistory. Quantum field measurements detect entangled particles within crystalline formations at sites separated by thousands of miles, indicating communication networks that operated faster than light speed limitations. The builders created information systems that transcended physical distance through quantum mechanical principles that precision of these quantum modern science is only beginning to understand. The communication systems required understanding of consciousness-matter interaction that extends beyond current scientific paradigms. Recent research in quantum biology suggests that human consciousness can influence quantum states through observation and intention, implying that the ancient technological systems may have been designed to respond to conscious direction rather than mechanical control. The builders created technologies that integrated human awareness with electromagnetic field manipulation on planetary scales. The stones of Baalbek stand as silent witnesses to capabilities that once existed and mysteries that endure. In their impossible precision, their mathematical constants, and their electromagnetic signatures lies evidence that human achievement has depths we have barely begun to fathom. The builders who shaped 1,000-ton blocks with surgical accuracy were not primitive peoples, but inheritors of knowledge systems that spanned millennia. Their monuments preserve memory of both triumph and catastrophe, encoding in stone the story of civilizations that rose, fell, and left only traces for us to decipher. Whether their legacy represents recovery from cosmic catastrophe or preparation for future threats, the Baalbek Stones remind us that progress is fragile, knowledge can vanish, and the great, sane achievements may already lie buried beneath our feet, waiting for minds worthy of rediscovering what time has hidden.